So again, I appreciate everybody jumping on this today for lunch. Hopefully, having a good conversation today. Kind of opening up this conversation, hoping to demystify the testing requirements of the energy code. So to answer some questions and to look a little bit deeper into what are the expectations associated with testing when we look at the energy code. Obviously, there's a little bit of difference between the different jurisdictions and their adoptions and what version we're looking at. So we're going to kind of keep it as high level as possible. But if you have specific questions, always feel free to reach out and ask. And I will throw this into the chat if I click the right button here. Throw into the chat our handout for today for those of you that might be interested in having it to kind of go along with the conversation. So as a reminder, we do have Xcel Energy does have its Texas Energy Codes and Standards Program website. There you can find different information, including some of the different technical resources that we've put together to support the program, including our visual inspection guides, our field verification guides. So those can be something that's useful. That's going to be a topic of conversation. I'm going to bring a couple printed copies when I come out on Wednesday, and so that way we can kind of go through them and what our hopes were, and then what we can maybe make changes on. And then again, we're also going to maybe try and sit down with a few people throughout the week. I'm going to try and sit down with you throughout the week and have some lunch and kind of just see what we can do to better help and assist you and your contractors in your community. So anyhow, when we talk about this concept of demystifying testing requirements, it kind of begs the questions, is always at the forefront of my mind, which is why do we test, right? Because I figure if we understand why we do it, then we can figure out how to better do it, right? Figure out the how we do something. And so when we look at the energy code, what are those basic expectations of the energy code, right? From the beginning, what we get, got the wrong slide there. Let me fix that one. Energy efficiency, right? So when we think about the energy code as a whole, what we're looking at is this concept that there's 6 chapters, and the first one is all about administration. And this is where I think we really get some of our guidance. Now, as code additions change, or if we look at as commercial for the multifamily residences, then again, we get a little bit different nuance, and we'll talk a little bit about those differences. But again, a lot of this expectation comes from what is that front end of the conversation? What does the code say we need to think about to verify? Now, why are we doing this? Is because we're looking for a building that's going to be effective and efficient in its utilization of energy over its useful life. And so again, that's the purpose, that's the intent of the energy code. And so how do we accomplish that most effectively? It's through this chapter 1 kind of gives us some guidance and says that when we're looking for building code, building components, right? The systems, the controls, the envelope, all those systems have to comply with the code, right? They have to comply with the expectations associated with the code. And what we see, whether we're looking at section 105 for inspections or in the older 2015 version, we're looking at section R104.6, we see identified this concept that there are going to be periodic inspections associated with construction. And that's what we're kind of using as a baseline to say, here's how are we demonstrating compliance? How are we building this the right way? And one of the things that the code, references more so in the commercial than it does in the residential is this expectation on testing, right? And that if there's an inspection, that leads to some questions, and there's a call for the inspector, for the building official to say, hey, I need this tested. We've got too many questions. Because what we're ultimately building up to is this concept that we see in section 106, which is the notice of approval, right? This is the certificate of occupancy that says, hey, we've approved everything, right? We went through the plan review. We've approved the construction documents. We've issued a permit. Now you've started the construction, and now we need to have this approval of the inspection process throughout the construction before we issue that C of O. And so ultimately what we're looking at is we want to make sure not only that it's properly installed, right? That what we get is a safe building that checks all the boxes, right? All of my inspections are done. It's good. Not only that, but also that the equipment that we're talking about, the systems, the controls, the things that we're talking about actually work, right? It's not enough to just say, and again, we'll see this in the context of maybe some of the conversation that we have, but it's not enough to just say, well, you installed it safely, it'll work. Well, that's not really the purpose of performance testing, right? Or testing something. We want to make sure that it's not just working, that it's there, but that it's working right. If we're going to get to a safe and a sustainable house or building, right? This section is also where we get that list of information that's supposed to be provided on our construction documents, right? This is where we have to have sufficient details to tell us that all these different components are identified. And again, it always begs the question, well, if you tell me you need this information, then why wouldn't you expect me to verify that it's installed properly, right? And so the only thing we see really that changes between the 2015, 18, and 21 codes is the introduction of this idea that you need to, in 21, beginning in the 21 version, identify the compliance path, because that again is going to be one of those conversational pieces that says, well, how do I verify, what are those expectations? Because as we'll look at here in a second, it really adds certain levels to the conversation on the expectations for testing, right? But when we think about, those foundational, what I call the foundational pillars of the energy code, we get these four ideas, right? When we look at energy code as a whole, we have four ideas: the building thermal envelope, the mechanical systems, the service water heating systems, the water heating systems, and the power and lighting expectations and controls. And so, when most people think of the energy code, they always go directly to the building thermal envelope. I know we hit it hard, but a part of it too is because we understand that it's not the only thing in the energy code, right? That it's the first and primary vehicle, because if we don't have a secure envelope, then whatever we do with the mechanical systems inside are really kind of wasted. And mechanical is where energy really takes place. It's not the drywall, it's not the insulation, it's not the vapor barrier or the air control layer, right? It's the mechanical systems that we install in the building that really are what uses energy over the useful life of a building, right? Once we install that window, right, it's there for the next 10 to 15 years unless we have a good storm, right? If we install that roof, it's going to be there until for the next 10, 15, 25 years, right? It's not using any more energy than it was the day it was constructed. Well, what it is doing is controlling, which we've talked about. That's the essence of all code, to control the building. And it's controlling how much energy we have to use to heat and cool, which are the primary functions of the mechanical and service water heating systems. So again, making sure not only that they're properly installed, but that they actually effectively work is kind of that part and parcel, right? Fist and glove relationship that the energy code works towards. And especially when we look at it over time, right? And as we get more complex, we see the more and more importance associated with those two things. And when we think about it, again, when we think about energy compliance paths, right? We think of, we see them as those three options of prescriptive, performance, and energy rating, or energy star, right? Depending on what kind of basis we're looking at it. But ultimately, we know that it's a little bit more complicated than that, right? It's not just give me a book and tell me what to do. It's which table are you going to follow? What design are you going to give me, right? So it's a little bit more complex than that. And then those performance measures, again, we're really looking at the same concept. It's just different measures, right? Is it miles per gallon, or is it, I don't know, kilometers per second? I don't know, right? Feet per second. That's kind of the question that we always ask ourselves. Are we looking at the cost to operate, the dollars and cents, or are we looking at the overall energy consumption that we get through a calculation, right? That we rate on some type of index or again, rating scale. So ultimately, these two, in my opinion, kind of go for the same thing. It's just dollars versus numbers versus uses. And ultimately, what we're looking, and each one of them will have its own expected requirement um, for basically how we test it, how we verify, right? Remember, our inspection process, and you guys know this just as you know, but the inspection process is not to be continual, right? We get called out to do periodic and random inspections of the building. We're not there the entire time from foundation to the last window or to final occupancy, right? We come in, we verify what we can see, and then we leave. We come in, we look at a mechanical system being installed, we leave, right? What I kind of see this as is, and again, this is something that changes dynamic, depending on compliance path and also uh, building types and things like that, is once in a while we start to see this. I see this a lot as that special inspection process. That's my brain immediately parallels energy code, testing with special inspections. In that, when we need to know from the beginning, right, what kind of tests are going to be performed, who's going to provide them, right? When we think about special inspectors, we get that special inspections plan, right, that says, here's what we're going to do, here's when we're going to do it, and here's how we're going to do it. Same concept in testing associated with the energy code. And so we have to fundamentally understand, if we're going to break this down into these 4 different concepts, we have to remember what is the purpose of the envelope. And the purpose of the envelope is to separate first and foremost the exterior environment from the interior environment. But when we start looking at it from the energy code perspective, it's all about enclosing, encapsulating, controlling conditioned space, right? And when we think about that thermal envelope, it's how do we isolate and control everything that's going on? And the first thing that usually comes to our mind is going to be that insulation, right? And like we said before, everything begins and ends with the thermal envelope. It's the furthest thing usually in our mindset. It's the first thing we think of, and it's the furthest out in the building because it is the boundary lines that we think about on how the building's going to operate. And with inside that concept, we understand that thermal envelope, however, isn't just doing one thing, it's doing multiple things, right? It's not just resisting. A lot of the first thing we think about the thermal envelope is thermal heat conduction, how we're resisting heat movement and heat control, right? Or temperature controls, right? When it was cold outside, which isn't very often, but it's becoming more often than it used to be, right? When it's cold outside, we want to control the heat inside. We want to make sure that we don't have uncontrolled heat loss. We can't stop it completely, but we can control it to the best we can. And so the same concept when it's hot, right? When it's hot outside and we have humidity, which I know is not often, but right, when we have humidity, we have heat outside, we want to maintain the temperature inside in a comfortable level for both occupants and those who might be members of the public gaining access to residential homes or again, other different occupancies. So again, that thermal envelope is doing more than one thing. It's not just about heat conduction. It's also about air control, right? And so they're tested, they have different expectations. And so part of that is understanding that if we've designed it to use a certain type of material based on certain characteristics or qualities, then we want it to perform the same way, right? It's not just the thermal envelope, and it's not just insulation, right? It's more than just insulation in a wall. It's all about the relationship between insulation and our air barrier, that hand and glove, that coat and shell, that thermal and shell relationship that we see, right? And as much as we put into design and as much as we put into the plan review process, it's really that inspection that drives compliance, that reminds us what compliance looks like. And again, we can't be everywhere at all times. And so that's why we see from time to time these testing expectations and these commissioning expectations. Commissioning is a term that most people associate with mechanical systems. When you really look at it, it's less about mechanical and it's more about the expectation of the system. I've received envelope commissioning reports as a building official because, again, it's just a concept that people understand. But again, we can't do everything from the desk. We need people out in the field doing these inspections, and we, again, can only do so many of them. we've created, again, these air barrier field guides, the insulation field guide, the mechanical field guide, to help guide this conversation, because we understand this is one of those things that when we see on a national scale um, buildings not performing as designed, it's because of things like this. It's a lack of education in the field. And so, to the extent that, like I said, this is something we're going to bring up next when our in-person training. I'll bring a couple examples and copies of our field guides, so you can maybe hand them out and give them out to contractors and tell them, here, keep an eye on this. This is something to look for. Here's a little headset, or a little not headset, a little heads up on what to expect when you're doing this type of installation. Right, but it all begins when we think about the building thermal envelope and the testing and verification of that system. It all begins with asking the question, where? Where is it? Right? The code tells us we're supposed to identify it on our construction document, but where is it? Because that's going to be one of those key considerations when we think about how does it actually traverse the building. And again, it becomes critically important when we start talking about the need to separate some of the different spaces that we see in our buildings. Right? If we have a vented attic versus an unvented attic, right? Then that starts to change what our expectations are for the whole system. And again, one of the things that I was brought up again here recently is this concept of rooms that contain fuel burning appliances. And it's not the appliance itself, right? It is the combustion air, the uncontrolled access to combustion air that's going to cause the problem, and why we need to think about how and where we locate equipment and where we locate ductworks, right? We see this duct right here. We can kind of see it crosses over into unconditioned space. So then we have to test it to make sure that there's no leak here, because a leak in this, we're going to zoom in here a little bit. A leak in this duct, this 8-inch duct that passes through the deck, through the garage, the unconditioned garage. If there's a leak in it, it will have a completely different impact than if the leak was in the master bedroom, right? As long as it's inside that conditioned space, that leak will actually still be within the control of the building. If it's outside, then we're just losing conditioned space, conditioned air into a space that, again, wasn't intended to operate, which can, again, affect how the mechanical systems operate. So again, it's a question of again, identifying where it is. And like we talked about before, when we talk about multifamily structures or larger residential structures, remember the energy code separates out, R2s, 3s, and 4s, rooming houses, dorms, hotels, motels, assisted living facilities that are 3 stories and less above grade fall under the residential provisions. Now, as we talked about when we talked about the air barriers, right, the code also kicks them back to commercial, but at the same time, it falls under the residential provisions. So it's trying to find that balance, right, of where is the envelope and what is it doing, and what are those different barriers? Because it's in both thermal and air barriers, right? It's not just one type of barrier; it's a system, because not all insulation and air control systems or layers are the same, right? It's about identifying what is going on, right? Are we looking at a system that works collaboratively with more than one material? We're looking at a material like a closed cell spray foam, which does multiple things. And again, how is it performing in that function? Because when we ask the question, how does it get done? It's kind of like I think about this when I think about a conversation I had with my son the other day. I'm not talking, maybe your parents said this, I'm not talking to hear myself speak, right? I'm imparting wisdom for your benefit. The same concept when it comes to, I'm going to jest, when it comes to architects. They don't draw just because they like to, right? They don't, it's not a question of, well, I see a break, I'm assuming you wanted me to stop the insulation too, right? That's not what that meant. That's a continuation line, right? But again, we want to make sure it's identifying how it's installed, right? That different materials have different both characteristics and methods of installation, different functions that they perform, right? Again, whether we're talking about barriers, air barriers, smart uh, resistive material, smart vapor barriers, all that kind of thing. It's a question of how is it being utilized, and a question really of how well is it being installed, right? We understand how it's supposed to be installed, right? There's certain expectations on the envelope, but how well is it being installed is really the question that we try to find through this testing concept, right? Understanding why, figure out how. The real question of why we're testing is because we want to find out how well this is performing as a function of our building system. And it includes not only the insulation, right? It includes the insulation and the fenestration, those doors and windows, because proper installation of those systems is going to be critical to controlling our building's thermal envelope, controlling our heat loss and energy consumption, which is the goal of the energy code. So in section R402.4, we see the identification of the air leakage controls, right? We start to see they're laid out there for us to look at these different types of questions when we start to evaluate air leakage. Now we've talked about it to some degree. Ultimately, what we're looking at are really the question of how's it designed, is it properly installed, and how do we verify it? Right? We've looked at this in the context of plan review before, right? Air leakage controls and what we expect to see for both the location of materials, the actual design, and then some of the other considerations. But what the code is really trying to get us to is making sure that is asking the question, how well did we follow the manufacturer's installation criteria, right? How well did we do? Because ultimately that's going to be the test. You know, and it's like when we were probably in elementary, right? We took tests in school, and then the teacher would say it's really more of a an experience than it is a grade. So pass your test, pass your math quiz over to the guy next to you. He's going to grade it and pass it back, right? Because what we're looking for is how well are you doing at doing this installation over time. Now remember, when we talk about those components that are part of that air barrier testing, we're talking about, lost my mouse there for a second. We're talking about, again, these types of assemblies and components, right? And the difference between the 15 and the 18 and the 21 is just some further, I call it refinement and clarification. But again, it really does drive back at that question is, again, what are the barriers? Where are they? What are they? And how are they being installed? Now, one thing I tend to do when I start to identify these or talk about these systems is I always go back to, at least as a building official, I would always go back to the commercial code as well. I'd play on this one, I would kind of play both sides of this conversation because the commercial gives us some materials that were typically going to be meet the air permeability requirements of the code to be used as part of an air barrier, right? So it's not just one type of material that can be used for an air barrier. There's actually a list of 16, right, when we really get into it. And so again, different types of material can be utilized as part of that system. And I would always, as the building official, say, hey, okay, you've got OSB in there, you got multiple components that could perform as a air barrier. Which one are we talking about, right? When we come back to test this, where's the barrier? Where's the final line in the sand on how this is going to be tested, right? And that same thing, there's not just materials, but there's also assemblies like our concrete walls that are properly installed, painted, grouted, sealed, and other types of again, wall assemblies, right? If they're done right, how do they perform in compliance with those, again, those expectations we see in the table? And part of it is going to be understanding that there is a proper method of installation, right? And it's a question of who's verifying that material. Again, we do the systematic periodic inspections. This to me is that depending on what we're looking at, again, if it's a multifamily, if it's a single family, who's going to be there the entire time watching it? Well, again, is it me or is it going to be some approved third party? That's a conversation that we should know from the beginning so that again we don't have this last minute, hey, I was supposed to get this inspected 3 weeks ago. Who's going to come out here and do that? Well, it's not going to be the building inspector. You should have had somebody do that verification themselves. And so again, we're verifying not only that we understand the systems, but also how they're being installed, right? Again, we're going to be looking for characteristics or system penetrations that can affect air leakage, like the ones we see here, right? There are certain responses that require different um, corrections, right? Taping is not always the solution when it's not the right tape or the right setup. We got to think about the entirety of the system. Again, are we talking windows? Are we talking air spaces? Are we correcting for pressure differentials? And when we think about that testing expectations that we see in the residential code specifically, I always want to remind us that there's always exceptions, right? There's always going to be an exception. But generally, when we talk about air leakage controls, the goal, right? The expected end is 3 air changes per hour. Now, one thing we saw the change from 15 to 21 in that process is we went from 3 to 3.0, right? Because apparently that was, we wanted to make sure that we weren't rounding down and getting 3.4 or 3.2, right? So 3.0 air changes per hour. And there's going to be certain things that we're expecting to happen during that testing process, right? And again, that's something that we as inspectors are maybe not responding to or looking for. But again, we need to make sure that those expectations are there during that testing process. And again, when we think about what that air leakage rate is, 3 air changes per hour with a maximum of 5 air changes, because again, there are compliance paths that may say we're going to have a little bit more air. We may allow for greater air leakage because we've done something else somewhere else, right? We've improved the efficiency of the equipment, and so we're okay with a little bit more air leakage. We whatever that might be. Again, it gives us a target as well as a maximum air leakage calculation. Now, where this kind of starts to become, to me, a little bit more interesting when it comes to air leakage is when we start thinking about our multifamily. Because remember, our multifamily are going to follow what we see in the commercial side as well, right? When we start talking about more than 2 family dwellings, we start talking about our townhouses and stuff, not townhouses. We start talking about a true multifamily unit. And so they're going to have a little bit higher or a little bit less, a little bit higher value, which means a little bit less control over air leakage, right? Because they're going to be following the commercial provisions at 0.30 CFMs per square foot. And so versus the 0.28, which is what we were getting for 3 air changes per hour, right? That's the equivalency between the two. And what the code says is that sometimes we understand there might be multiple dwellings in a building, right? If we're doing, let's say, a 12-unit, 3-story, 4 units per floor, we're going to have 12 units being inspected. Then we have 2 options. One, we can test the entire building, right? Set up the whole set. Or we can go through the methodology that allows us to test 20% more, at least, with at least 7 units. Right. So if we had 12 units, we're still going to do 7 units. Right. And so what we're looking for in this scenario is the code gives us expectations for testing dwelling units on multiple floors, one under the roof, one on the ground floor, the largest unit, and then whatever else we got to do. And then we average them based on square footage. Right. That's the expectation when we test. Again, it's either whole building or we can go into this unit by unit if it has more than 8 units, right? So if we're doing, let's say I'm just going to use an example, and hopefully this is not, there's no secret here because I know nothing, right? Let's say we're going to put a new hotel out by the airport, right? Buc-ee's wants to have a hotel nearby, and so we're going to have a 3-story hotel that's going to go in. It's going to have 300 units. Right? We would still follow the residential provisions, and we would allow them, instead of doing the entire building, to follow this section here for dwelling unit testing, right? So instead of doing 300 tests, they're going to do 20%, which is 60 tests And we're going to get into, in order to determine, is this building going to be working effectively, right? Is it performing when it comes to the air leakage controls? And so what the code says is when we do that test, we want to do it in an unguarded blower door test, because ultimately this unit should be responsible for only this unit. We can do a whole building, or we can do unit by unit. We don't create unnatural pressures surrounding that unit, right? So that way, if I'm in the room and there's nobody around me, I don't have to have it kicked up to 75 to get it to 68, because there's so much air leakage going on around me that I can't maintain a sensible, reasonable energy rating or temperature, right? So this is the kind of thing that we see. Again, this is the blower door that we normally see performed and associated with this type of work. Now I've got a video here. If we have time, I'm going to skip it for now, where Robbie Shores is going to would walk us through a blower door test. Right? We may have seen this before. If not, again, I'll try and show it. And when I put these up in the website, hopefully I'm trying to get that done this weekend, I'll include the entire video as part of it. I'll just insert the entire 11-minute video. If you have time at the end, we'll come back and watch it. But one of the things that we see is, again, not everybody has the access to the blower door system, and so once in a while the code identifies alternative means and methods of verification. And one of the ones we keep talking about a lot that the code recognizes in commercial a little bit more than residential is the use of thermal imaging and and smoke tracing, right? Because what we're looking to do is identify areas of heat loss where we're going to have airflow, and then we're going to identify methods of correcting that. So when we start to go out, we can see, again, in a residential setting, we can see where we have missed, where that insulation, they thought that break meant no insulation, right? So we can see the breaking of that continuity of our thermal envelope. But we can also start to see the impact of the air movement on our thermal bridging components, right? We're starting to see air movement, right? We're seeing air loss and heat and cooling passing through the system. And what we're going to end up experiencing over time is condensation, which is always bad for the interior wall assembly. And then we're also going to have, again, equipment not performing, depending on the type of deficiency, the equipment's not going to perform effectively. And so if we have a building, let's say that we're talking about a multifamily or mixed use occupancy, and so we've got an interior surface, but we've got some doors that aren't properly sealed or weather sealed. What we'll see is this huge swing, a 20-degree swing in that space. So again, that space is going to get hotter than it's supposed to, get colder than it's supposed to, depending on the weather pattern. And so again, those are the things that we can identify and identify corrections, right? Because we understand why we're doing it. We're trying to control the air movement so that our equipment works efficiently. And so when we identify and verify that thermal envelope, this is part of what we're looking for. Again, if we have a barn dominium, right? I love a good barn dominium. And so sometimes those are made with metal frame buildings, right? Metal frame, metal skin, metal walls, metal building. Excuse me. And so if it's not installed properly, because we don't typically see that a lot in residential, we're going to have thermal bridging impacts, right? And we're going to have 107-degree steel frame inside our building, right? I've got a buddy, a contractor I know, not a buddy, but a contractor I know, who builds steel frame houses. They're literally they're metal buildings, and they just put up the insulation and then they go, right? They move in. And so again, we want to make sure we're paying attention to that kind of thermal bridging. And this is a good resource. Now, again, I suggest this for contractors just as much as inspectors. But having this technology, having this alternative means in your mind is a way to make sure that the building is going to be efficient and effective when it comes to how it operates. Here's an example of one I was doing at a conference. Right, we're doing a little training, and I took a picture, and interior temperature was 74 degrees, but the receptacle in the room was 50. Right, that's a 24 degree difference between the receptacle and the wall. Now, We talk about the expectations in table 402.5, right? We understand we're supposed to seal those, or at least protect against air movement and transfer. What do we know is going to happen with the air that goes from 74 to 50? It's going to create condensation. And the one thing we know about electric is it does not like water, right? So when we have this water and electric combination at a wall receptacle, the response is, well, we need to treat that. We need to go in and seal this properly so that we don't have continuous air movement. And we also see the impact on thermal bridging, right? This is not a steel building. This is a wood frame building. So how much are we losing on that? Are we in direct contact? There's some questions I got for that one, right? And so again, we're trying to think about the doors, the access points. Where are we going to see air loss as we think about air loss? This is somebody's house. I'm not going to tell you who. I opened the door. I unlocked it, so that's why it's so cold, right? It's not normally this cold. And so you can see that the difference between the wall and the door frame, right? You've got normally it's 68 degrees in my house, and you got a 53-degree door jamb, right? So you're going to have 18 degrees of, at a minimum right there, 18 degrees of difference that will cause condensation, especially with interior humidity levels versus exterior humidity levels. Same thing with this basement door, right? If the basement door is not properly sealed, then we're going to have condensation. We're going to have, again, if it's 70 degrees inside and I got 47 coming in, that mechanical equipment is going to run more than needed, right? And again, we're also talking about potential moisture accumulation at a wall assembly. And then the other thing that I think is important to think about is cookies. No, I'm just kidding. That has nothing to do with what we're talking about. That's just cookie dough, right? And we see how cool it is, nice and cold. Anyhow, moving on. So when we think about what are the expectations of the system, the code tells us that when we talk about duct systems, right? Talk about the envelope. Now let's move on to the next piece, right? We've talked, we know that there are 4 pillars, and the next one is going to be mechanical. The code talks about as a mandatory requirement under the 15 and 1821. It's also continued through the IMC, through the mechanical code, that there are certain expectations associated with how mechanical systems are properly distributed, right? The mechanical system is designed to provide us that space conditioning, ventilation, and it includes a proper duct design. What we're expecting that to do is that as part of this process, we're evaluating how well those ducts are doing, right? That we have a rough end test, we have post-construction test, right? We have duct testing to make sure that the duct is performing the way it's designed. Now, we know that we don't do duct testing when we're talking about ducts that are completely within the building thermal envelope, right? And so that's one of those exceptions that we recognize in the code. So if everything's inside the conditioned space, that's a great reason to know where the envelope is. Then we don't need to test the duct because again, the loss that we experience will be inside that conditioned space. But if we're thinking about these in those larger commercial operations, right, those larger multifamily, 3-story hotels, motels that fall under the residential provisions, it reminds us to kick back to the mechanical systems, kick back to commercial. And the commercial code tells us that we need to have commissioning reports, right? That there are certain information that we need to provide prior to the beginning of the process, right? Again, just like I said, like with the special inspection plan, we need a commissioning plan that tells me who's doing it, what they're doing, when they're doing it, right? Who, what, when, and where is going to be answered in that process. So as part of that permitting, we're going to say, okay, what are we doing in this system? Now, this is, again, where we get a lot of plan reviews for residential. And, I've told you this before, it still drives me up a wall. We get everything designed except for mechanical, and the mechanical comes in as the deferred submittal, where, hey, I need to see, and I literally have 3 that I'm supposed to work on today, where house has already started. Now you get your manual JS&D, need to see the duct design, need to see equipment design, equipment selection, so I can evaluate is this going to be the right system? Now remember, I'm looking at that you have a design that with some specific things I'm looking for, right? I'm looking for the right jurisdiction, the right elevation, the right components in that design. I'm not rerunning the design. I'm just saying you have a design. You've selected equipment that matches that capacity. So I have a load, a capacity, they match. I'm good, right? That's the end. I am not redesigning their system. But what that does mean is I have to understand what is eligible or part of a system that is going to get commissioned. And one of the things I think it's important to understand is too, not everything is code-based. I see a lot more, and have for many years, seen a lot of financial institutions saying, hey, we want to do this. Or as part of a rebate, we want you to provide this information. So again, sometimes these requests, this information, is not because the code is telling them, it's because there's other institutions or factors that say, hey, we want to know how well is this performing? How, before we give this rebate, what, show me that this actually works, right? So you might see that. When we think about what's expected as part of the commissioning report for those multifamily systems following the commercial provisions, there's a requirement that we also provide not only verification of everything that was included in our plan and our details, but that we also get this preliminary commissioning report. That this preliminary, before we occupy, before we issue that CFO, we need to see a preliminary commissioning report on those multifamily buildings, because what that's going to tell me is how well is this system performing. Now, the reason we don't wait for final commissioning is there may be some things that are nuanced differences that are outside the scope of our conversation, right? It's that same thing that we see every once in a while in a housing project or house, a normal residential home, where this is not a code safety issue, but it is a contractual issue. You need to deal with it, but I'm going to issue the CFO, right? Not a temporary, I'm going to issue a real CFO. And the similar concept here. So if we have a program or a project that has a commissioning plan, we're going to get a preliminary commissioning report at the end that says, hey, they're right there, but they just need to be dialed in a little bit more. We're like 3% off the standard of deviation. We're good, but we need to. We're not getting 1,100 CFMs. We're getting 10. We're getting 1,000. So we need to do this. Do we want to expend the time to get that a little bit more efficiency? Again, that might be something that's being held by the owner. And so we're more likely going to either get some kind of acknowledgement or copy of that preliminary commissioning report. Hopefully that made sense. I didn't go too far in talking about it. We got a video quick. Let me look. Yeah, we got time. So we'll do this quick video because I think duct testing is, we can get the idea of, it's a little bit shorter video of Robbie doing a duct test versus when we see it. Oh, you know what I didn't do? Click. Share sound. Share sound. There we go.
To outside.
So let's do this.
Hi, in this video we're going to use a duct blaster and a blower door to measure duct leakage to outside. So just like what we did with the duct leakage test, we're measuring pressure in the house in relationship to outside the house. Before we were measuring the duct pressure inside the duct in relationship to outside the duct. So I am going to measure the house pressure, which would be the input in reference to outside. So my first goes here, and then I'm going to be measuring the fan pressure in relationship to the house. And again, that fan pressure gets translated into a flow number. But we're actually, when we do the blower door test, we're going to do an automated test. So the computer will do all the measurements for us here after we've set it up properly. Before we do those tests, though, we're going to do a duct leakage to outside test. And the duct leakage to outside test needs a blower door and a duct tester running simultaneously in order to get that measurement. What we're doing is we're pressurizing the house with the blower door, and it works off the principle of you need a hole and a pressure across that hole in order for air to move through a hole. If I have a hole inside the house and I have equal pressure on either side of the hole, then air won't move through that hole. So if I have a duct leak that's inside the house, I won't be able to measure that because I pressurized the house and the duct to that 25 pascals of pressure. But if I have duct up in my attic, for example, I don't have the same pressure in the attic as I do inside the duct, so I'll be able to measure the flow of air flowing out of the duct in that unconditioned space or that outside space, that duct that's outside the building envelope. So we're going to start by pressurizing the house and covering the fan inlet to baseline. We have to baseline it, and then we'll pressurize the house, and then we'll take the measurement here. So.
And like you said, so what we're doing is very similar to a blower door. Blower door test would be the entire structure being pressurized and identifying leakage over time. And what we're doing here is he's pressurizing the home, and then the duct itself will be following that same pressure. Blower door, we're just testing the building, and you isolate out all of the duct. Now he's including both.
Pressure, I need to cover this inlet to separate it from the outside. And then we'll do our baseline pressure here. So this is just seeing what the normal, in essence, stack effect is happening in the house over a period of about 10 seconds. So we have a stack. We don't really have much stack effect of negative 0.1. Okay, the next thing we're going to do is pressurize the house to 25 pascals. That's going to be our reference pressure in the house. And I'm going to let the fan, what's called cruise. But I need to turn on the fan. So air is now coming into the house. We're blowing up the house like a balloon in essence. And I'm going to connect the duct system to this air that's coming into the house. Okay, so we have pressurized the house using the blower door. We've opened up the fan opening of the duct tester, so air is going into the duct system and air is in the house. So if I have a hole in this piece of duct here, air would not be going across that hole because the pressure inside the duct and the pressure outside the duct are the same. So you need two things for air to move through a hole. You need the actual hole, and you need a pressure difference across that hole for air to move. But up in the attic, if I have duct up in the attic, the pressure outside the duct is not the same, so the air being pushed through here would be leaking outside, and that's what I'm going to be able to measure here. So we turn on our gauge again and tell the gauge what device we're using and how we're measuring. We're measuring in cubic feet per minute here. And I want to see if I have a pressure. If I have a pressure in this duct, and I have a very small pressure, I'd be able to accentuate that pressure by adding a ring here. And that pressure is about negative 0.6 pascals of pressure. So my goal now is to zero out that pressure. So I'm turning on the fan, in essence, to chase the air from the blower door that's going through here and zero out that pressure. And once I've zeroed out that pressure, I've equalized the flow that is leaking out of the holes that are up in the attic duct system. So I have about 35 cubic feet of air that is leaking outside the building envelope. And that is a CFM cubic feet of air, and that is our duct leakage to outside, and that would be considered the energy penalty that could be traded off using the simulate performance pattern.
And so we saw there where, again, he's pressurized the house, and now he's testing the actual duct system. So again, it's part of that relationship about how we look at the equipment and how it's going to operate. Here we got an example of one that's in a little bit larger facility. So again, you can add more blower door fans to the system in order to do a larger test. But if he's getting 35 CFMs of air leakage in a building of that size, he's within what the code would say is an allowable, most likely an allowable square footage. So when we think about when we see these out in the real world, right? These are some pictures of some that we did here recently. So again, we're out doing blower door tests to verify, are the systems in place in residential homes? So this is how we know. Is the envelope working? Is the mechanical system the problem? Here they're installing a blower, another duct blaster onto a mechanical duct system. So we can see where those leaks are taking place and make that home more efficient. Again, this is a little bit larger example, maybe for a loading dock area that we might see in a commercial project. And so just to show that we can see them at different sizes, different situations. Again, if we're part of a hotel or something, ultimately what we're doing is we're making sure that the system, not only the ducts, but also some of the controls, right? The controls that would tell the equipment to shut off when I've left the balcony door open for 3 days, or if I have if this balcony isn't closed, then I don't want this air handling system operational, right? And so I want to make sure the controls are working right and we have the proper isolation. And like Robbie was kind of alluding to, some of these conversations are things that are handled as part of a choice that we make on our compliance path, right? It will have an impact on a project that uses one of those simulated performance alternatives, right? Whether we're using the total building, the simulated, the energy rating, the Energy Star. Those are all looking at those tests to see not only did you install the right material, but how well is the building performing. One thing that you'll see, and again, especially we'll see this more, at least for the next couple of years, I'd say, only in the true multifamily projects that follow the commercial side of it, is this functional testing for lighting controls. And really what that's looking for is, like we talked about yesterday or last week with exterior lighting, is, are these controls working properly, right? I'm not going to go out and sit under the parking lot and wait anymore, right? I told you that last week. That's how they picked on poor Josh when I was one of my first years as an inspector. Go sit in the parking lot and see if those lights turn off after 30 minutes. What? Just sit there. Don't move. If you move, they'll reset and you'll be there all night. Now we have testing to do that, right? We can send a commissioning report and not say, hey, send the low man on the totem pole out to go and sit out at the parking lot at the multifamily building, because that doesn't look awkward, right? But again, we're testing those different controls, because what we want to make sure is that if we're installing them, that they actually connect properly, that we have the right timers on places. When I bought my house, I think I may have already told the story, but if I didn't already, when I bought my house, when we first went to go turn on the air conditioner, one of the times, or the heater, the furnace, because we bought it in the fall, it didn't turn on. And so I was like, what's going on? And I looked, and the device, the actual thermostat, was dead. So I replaced the battery, and I thought, well, that shouldn't happen. It should be hardwired. And so I went and checked, and they didn't actually wire it properly, right? So did it work? Yes. When it had power, it worked, but it wasn't wired properly. And so that's kind of the question we're asking is, do they work, and do they work effectively? And I'm not walking around the house wiggling my hand in front of every occupancy sensor to see if it turns on and come back later, right? That's functional testing. I'm not doing that at all 300, hotel rooms. Not going to happen, right? And part of what we're seeing, again, the requirements of the code from 15 and on, is that we are identifying the qualities of the building through our R401.3 certificate, that little energy compliance certificate. And so again, this again aids us in understanding, how does the system work? What is the airflow? What is the air leakage rate? What are the different components in that building, and how are they performing, so that an owner knows how their building is supposed to be operating. So there's more than just a checkbox from a building inspector, but that they have this qualitative evaluation of some of the equipment, some of the systems, some of the controls, the envelope, so they have a safe home in the end. I know we got a few minutes left, so if anybody has any questions, obviously we got some time for some questions. Just as a quick reminder, next week we're going to get into plan review associated with fenestrations and doors and that process, kind of building off of what Hope had talked about a couple weeks ago. Then we're going to get into res check on the 17th. That's going to be what I'm going to enjoy talking about res check. I love a good res check. And then we'll get into mechanical systems before we get back into interior lighting at the end of the month. Now, remember, if you have any questions, you can always go to the survey. And if you're an architect, obviously put your information there if you've not already done so. Remember, we have that in-person training in Amarillo on the 9th. If you're interested in coming, please let us know. You can scan the QR code and just connect through, I think it's an Eventbrite. I can't remember what I used. But it'll be from 8:30 to 12:30. I have sent out some emails and questions as to whether or not people would be interested in staying for another half day on commercial, or if you want to try and combine commercial residential into a conversation. Just let me know if you're interested in attending and what would be a useful topic for you. We're looking at, again, a little bit of the more holistic approach to residential energy code compliance as a part of that training. But again, if there are specific questions that come up, then that's what we're going to do to address them. But again, that's going to be at the Sims building downtown on Wednesday the 9th at 8:30 to 12:30. Now, we're going to have breakfast. I'm looking at breakfast burritos, so give me an idea how many people to prepare for. Sometime around 8 o'clock when we can get into the building. So if you have any questions, feel free to reach out to us. Make sure if you have technical questions, feel free to use our TX helpline at shumscoda.com. You can ask any of your questions. If you have questions about, a res check or a product or some design question, feel free to reach out to us either individually or through the helpline so that we can give you the information that best helps you. Remember to you can find all of our resources on our website. And again, if you have any questions, we are here to be an assistance. Like I said, hopefully when we get in town, I'm going to be there a little early and hopefully can set up some lunches just because I want to see what's good to eat in your towns, right? Because I'm all about the food. And so, again, if you have any questions, feel free to reach out to us, TX helpline at shumscoda.com. You guys have a great day. Be careful. If we don't have any questions, you guys can obviously go. And hopefully we will see you all at the